Okay, so we're looking at finding the surface area of a hexagonal pyramid. The first thing you want to do to find the lateral area is remember that your lateral area formula is equal to 1/2 times the perimeter times the slant height of the figure. So when you look at your figure, these sides have a length of 6 around the base. So if we want to find the perimeter, we're just going to add all the side lengths together to get the distance around the outside, or multiply them by how many there are. And in this case, there's 6 of them, and each of them has a length of 6. So we're going to do 6 times 6 to get the perimeter of 36 for this particular hexagonal pyramid. Now the next thing we're going to do is look at our slant height, which is actually given to us here in the figure, has a length of 8. So for the lateral area, we're doing 1/2 times our perimeter, which is 36, times 8, which is our slant height, and all together, that's going to give us 144 units squared. Okay, so now that we have the lateral area, we want to look down to finding the total area. So remember that to find the total area of any pyramid, it's going to be equal to the lateral area plus the area of the base. So since we already found our lateral area, all we need to do now is find the area of our base. So if you look, our base is a hexagon, and for any regular polygon, the area of that figure is equal to 1/2 times the apothem times the perimeter. Now we already know that our perimeter is 36. We stated that earlier. But now we need to find the apothem. So keep in mind that when you have, and this is just a rough sketch of a hexagon, you can divide that into 6 equal triangles. Okay, now since a complete circle is 360 degrees, that means each one of these, if I divide that by 6, is a 60-degree angle, which means that we have an equilateral triangle here, 60, 60, 60, since it's also symmetric. Now, if we took just one of those triangles and blew it up a little bigger, we want to sketch in our apothem. So by drawing in our apothem, that's the perpendicular line that comes straight down from one of the vertices, and it forms a right angle with the opposing side. So since the entire length of one of those sides was 6, that means that when we drop our apothem down, this side now has a length of 3 because it's halfway across. Now, since this angle was 60 degrees, but we cut it in half, now we have a 30-degree angle here, and we have a right angle here, so that leaves this one to be a 60-degree angle, and we have a special right triangle. So remember your 30, 60, 90 special right triangle rules, which say that the length of the long leg is equal to the short leg, which is 3, times the square root of 3. So that tells us that our apothem A here is equal to the short leg 3 times the square root of 3. So to get the area of our base, we're going to do 1/2 times our apothem, that's 3 root 3, times 36, that was our perimeter. And when we do that multiplication, that is going to give us 54 square root of 3. So now that we have our lateral area and the area of our base, we're going to add them together to get our total area, and it would just be 144 plus 54 root 3 to get the total area of this hexagonal polygon.